grab a piece of paper?
Yes.
What do we take that the test thing? That was at the beginning of the month.
Next week.
On a Monday. Then when? I thought that's our last day.
What did you say?
I thought that was our last day though. I don't know if I'm leaving.
So we're silently and independently right now. Take one more minute, wrap up your do now.
I really want to.
Finish up that last problem you might be working on. Alright, let's go over them. Can someone, in their own words, for me, please, explain what distributing is? That first row of questions in your do now, all you did was distribute. Somebody that is confident in what distribution is, please tell me a little bit about it. Lizzie, I know you know what distribution is.
I want to answer this question.
Why not?
Because I'm on this finished with this.
But we're going over it right now, so I need you to answer and tell me what you think distribution means.
When you multiply the outside of the parentheses, that's all.
Okay, so Lizzie takes whatever's on the outside of the parentheses and multiplies it by the inside of the parentheses. Chris, do you agree with that? Is that what you do? Yeah, so distribution is just when we take whatever's on the outside of our parentheses and we distribute that to whatever's on the inside of the parentheses. What about inverse operations? Can somebody explain to me what an inverse operation is? Carlos? What are inverse operations?
Inverse operations is when you either subtract to isolate the variable or add to a set variable, in which case you then have to divide or multiply to find variables.
Is it always addition and subtraction?
No, it's the multiplication, subtraction, or
Okay.
addition.
So Evelyn, what's the inverse operation of multiplication? What's the inverse operation of subtraction? Exactly. So inverse operations is when we do the opposite operation of whatever is on our problem in order to isolate the variable. So for those bottom three questions, we got an answer for x for number 1. Lizzie?
X equals 3.
X equals 3. Number 2? David? Did anybody get an answer for number 2? Corbin got x equals 12. Number 3? Raise your hand if you got an answer for number 3. Evelyn. Evelyn got x equals 5. Perfect. So, that was a little review of solving complex equations. So, like I said yesterday, your do nows for the rest of today are going to be involving complex equations, and then we're going to get into area of triangles too. So that by the end of today, your do now in Mr. Storm's block is going to be like a redo for your exit ticket on complex equations and areas of triangles, right? Everybody gets that? Good morning. All right, so moving on. You guys are going to work in your table groups for this next part. Carlos, you can just move over to this no table since you don't have any on your table. Yeah, for the Explorer. And you're going to use your knowledge that we learned yesterday about the Pythagorean theorem. If we don't remember what the Pythagorean theorem is, we still have it written right up here to jog your memory a little bit. All right, so you guys are going to talk in your tables, and you're going to try to figure out this problem with the tree and the sun at the bottom there. All right, so we know what the Pythagorean theorem is, but in this problem we have a little length that is labeled x, and we want to try and find out what that length is. So how can we use our knowledge of the Pythagorean theorem, our knowledge of the numbers that are here in this problem, talk with your table partners, work it out, come up with some ideas. It can't be so bad. You've got 2 other teammates here you've got to talk with. You guys all have to be on the same page. It is? What's that? Or does it matter? Okay. You've got 3 table partners to check with.
I wouldn't have that.
Huh? So, what does C stand for in your Pythagorean theorem? Right. Is that the hypotenuse of your triangle?
Yeah, yeah.
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 I got a question.
Yeah, but which one's waiting?
I'll be right over
It
there.
don't matter.
I don't hear you talking at this table.
We already talked. We don't know how to do it.
Yes, you do. Sure you do. You might not know how to do the whole thing, but you know how to do parts of it.
I thought I did, but I guess I didn't.
We'll look at your Pythagorean theorem.
Are we doing like
Talk about which of these variables you might know, or which pieces of the variables you might know, right?
What's the 11 a.m. and the 9 a.m. here?
Oh, do both for practice. You can give me the decimal, but then also give me the simplified radical. Yeah. Do you know what we're doing? Then you remember what we're doing? Okay. So that's your A. You put 30 as your B. Can 30 be B?
Let's go, bro.
This triangle
This is still having a different
isn't the right triangle. And this leg,
so it's 90. C is 90.
Yeah, no problem.
C is just 90. You have to square it, like,
Well,
square it like one.
So we went over the Pythagorean theorem.
What's the answer?
Right. Do you remember what A, B, and C stand for? So yeah, C is the hypotenuse, which is what I'm concerned with. So you can go ahead and label that one. And Christmas, now, what your A and B are.
What about this?
And
X?
you have to solve for them.
It's not this whole side. So this whole
Oh,
side.
30X.
30 times X. At least
Well, look, there's 90 in there. That's why
Well, you're right, it left everything out.
I thought it would be 30X.
I'm totally kidding.
So it's 30.
You're close.
So I was right.
You're close. B equals 40. So what is B? Draw it on this picture. Show me what B is. Is it just that one? Or is it that? These 3 years. You use this triangle and you use this hypotenuse, right? So this whole thing is your missing thing. So 40 is the correct answer, but you're not there yet. 40 is the answer for this whole way. The question is asking me for X, for the short shadow. So how would you find X? I think you do. You know this whole length. It's 40. But you know this part of it is 30. You know how. Now you can help out Chris and Evelyn. Oh, I should the first time. I didn't know that it was right.
And we said, you, and this where it said that was 30
You had
plus.
any ideas?
Right, plus
You
30.
talked to Corbin and all? He's got some ideas.
Oh,
To show B, you have to write all of that.
Yeah, I do.
is that right so far? Okay.
So far, it's like A, this would be A, right?
Yeah.
Now you're trying to make B. B was 2 things. It was 30.
Oh.
So how would you show that? Like, are you just gonna write those numbers by themselves?
Right now,
Put them in
you
parentheses?
get this. Octavia still needs some help.
They're all B, right?
Can you?
30 plus
No.
X is B.
How'd you get the answer? Pretend you're telling me.
Because all of the B.
So what would I erase for
Yeah. Corbin's gonna tell you a little bit about how he got the answer. Right?
30.
So 30 plus X.
That's all B.
and then it would put equals 50.
So like all of that is B. Now, this is where you have the
Rainbow? Yeah? That?
1 more minute to wrap up thoughts with your tables. Just on this one.
I know, but I don't know how to do it. So
You're almost there. What do you mean you don't know how to do it? You got this. So what is, you didn't find X. You found, you used this as your A, right? You used this as your C, right? So that means your B has to be this whole length here at the bottom. So this B that you found in A squared plus B squared plus C squared, this B is this whole length. The question's asking you just for this little length. So you know that the whole thing is 40. You know that this piece of it is 30. How do you find the little tiny piece?
Oh, you put in the box. She said this whole thing is 40.
All right, 30 seconds.
Alright, so.
Take on 11. And then that's gonna show up again. So like if I had like if I had like 15,
Break down the B.
so I ended up down to like B, 225.
Focus back up here. We're going to go over this explore. Who found a value for x for our shorter shadow? All right, who found a value for x? I know some of you guys did. Lizzie, did your table find a value for x?
Yes. But I don't know.
All right, well, what'd you get?
I got 2 X's. So.
What'd you get for your second x?
10.
Lizzie got 10. Did anybody else get 10? Corbin, what did you get for your value of x? 10. We got 2 10s. Let's see if 10's right. For this, if we look back at our Pythagorean theorem, we need to label 3 things, A, B, and C. We know that to use our Pythagorean theorem, we have to be involving a right triangle. So the 3 things that we're going to label as our variables is going to be this, this, and this. Okay? The reason that we can't just use 30 is because you're going from here to here. Your hypotenuse is coming all the way down to here. So that means you have to connect this dot over here to this dot over here with the B. It has to be the entire length. It has to be x and 30. It can't just be 30. Okay? So when we plug those values in, let's say 30 is A, B we don't know, so we can just leave it as B. Thank you, Lizzie, you have to square it. And our hypotenuse, C, is 50 squared. When we square those numbers, what do we get here? 900. B is still our unknown because our whole side is unknown. All right. 50 squared is 2,500. To solve for B, we have to subtract 900 from both sides. Anybody get a value for this? 1,600 equals B squared. Thank you. This should all be squared. Now we have 1,600 and we have B squared, so we have to do something to 16. Square root of both sides. B equals 40. Are we done?
No.
So we know that our full length here is 40. And we know that a piece of our length is 30. And we know that another piece of our length is x. Right? We know that we have to add those together to give us our total value of 40. Right? So we subtract 30 from both sides. Subtract 30 from this side. We get 10 equals x. 10 feet is our smaller shadow. Cool? So you guys already figured out today's lesson. We're taking this Pythagorean theorem and we're applying it to triangles that have multiple triangles within them. Right? So go ahead and flip your notes over. Right there at the top is our theorem about the Pythagorean theorem.